Hi, my name is Chanseo Lee. In this video, I'm going to present my findings on correlational analysis of pH and volatility for pure dicamba, dicamba-glyphosate potassium, and Dicamba-Trichlorophenol. Dicamba is one of the most common herbicides around the world. In 2012, it was world's fifth most commonly used herbicide. The chemical name for dicamba is dichloromethoxybenzoic acid. Dicamba is used with other herbicides, such as glyphosate potassium and trichlorophenol to give much more efficiency compared to other herbicides. Thus, farmers prefer to use dicamba solutions as their main weed killer. However, dicamba solutions are too volatile. Because of this unfavorable feature when dicamba is used in spray forms, the remaining dicamba that is not absorbed by the roots evaporates and follows the wind flow. Most of the time, the evaporated solutions fall on the neighboring farmlands, and this non-targeted movement of dicamba is widely known as off-target movement. This unintentional movement of evaporated dicamba solutions can cause a big loss in crop yield. Because dicamba is a selective herbicide, which means it is specific to what kind of plant they are used to, it can be harmful to plants that are not suitable. So it may change the plant metabolism. Other than this, environment around the crop changes from suitable environment to unsuitable due to the toxicity of dicamba solutions. So this project is about investigation of the correlation between one specific factor that may reduce the volatility of dicamba solutions if controlled, and that specific factor is pH. First of all, pH of all three dicamba solutions of initial concentration were measured. Second, the concentrations of dicamba solutions were varied by using distilled water to change the pH. Then distillation for different pH of dicamba solutions was performed to measure the volatility. Then using these measured values, linear graph was drawn to observe any trend between the variable, and linear equation was made to model the relationship. Lastly, dependent pair t-test was progressed in order to see the significant correlation. My hypothesis predicted greater OTM, which is off-target movement, of dicamba with greater acidity. This hypothesis was supported by several previous research. According to a research paper published in 2019, authored by Thomas C. Miller, in order to lower the volatility, pH should be higher. This inversely proportional relationship between the pH and the volatility was proposed at the discussion section of the previous research, but they did not prove the hypothesis. So I tried to prove this relationship by measuring the actual value of volatility. The experiments were conducted using industrially preferred concentration, so that the pH measured for such concentration was used as the control. The experiments was then conducted recognizing that there could be possible effects on the volatility of dicamba solutions caused by concentration itself, regardless of pH. First, pH of dicamba solutions at industrially preferred concentration was measured. Then two more solutions were prepared varying its concentration from industrially preferred concentration. Next, using all these varied models, distillation was carried out to measure the volume of the condensed dicamba solutions, which we use for the measurement of volatility. Each experiment was repeated 3 times. After obtaining these data, linear graph was drawn and linear equation was set by using MATLAB to simplify the relationship. Then the dependent pair t-test was carried out for the pH and the distilled volume for all 3 dicamba samples. The t-test is a type of inferential statistic used to determine if there is a significant difference between the means of 2 groups, which may be related in certain features. The results showed that there is a positive correlation between pH and the volatility, contradicting the previous studies. Pair t-tests were conducted to examine the significance between pH and distilled volume for 3 dicamba samples. For the p-values of 0.0213, 0.1459, and 0.0255, for pure dicamba, dicamba-glyphosate potassium, Dicamba-Trichlorophenol, respectively. The relationship between pH and distilled volume of the 3 dicamba samples were proven significant. The statistical data produced by t-test showed that there is a trend. Higher the pH, higher the volatility. And this trend can suggest one possible solution to prevent or reduce off-target movement. Dicamba industries can set the preferred concentration in accordance of both pH and efficacy. In new standard concentration for dicamba solutions can be less efficient than the previous standard concentration for dicamba solutions, but it will be more beneficial in reducing the volatility of dicamba solutions, thus OTM. And it's eventually solving one of the biggest problems in agricultural society. Distillation could be not the best method of measuring the volatility. Therefore, taking different boiling points of dicamba solutions into consideration in its further research and development for a more suitable method of measuring volatility of dicamba solutions, disregarding the distillation method. Thanks for listening.